Hi all, John the Morgile back again with an update and extrapolation on a point that was raised in my latest video series, The Globe is Dead. I think it was in part 1 or 2, but before I get started, I just wanted to mention a couple things to all y'all out there. Firstly, I want to thank and let all my subscribers know I appreciate you guys. And I even appreciate those of you who disagree with me. I've mentioned this in a couple of previous videos, but something's going on with my subscribers. I've gotten several complaints of people noticing that they're getting unsubscribed from my channel without them actually doing it. And it's weird because I can look at my analytics and see that I've gained, say, 900 subscribers during a certain period and lost 90 subscribers during that same period. Yet my subscriber count, which I've been following this whole time, has only gone up like 300 for the same duration. So something fishy's going on with my subscribers. So just as a reminder, if you've been subscribed to my channel, please, check and make sure that you're still subscribed. And if you're not subscribed, then subscribe anyway. It's free. Haha. Anyway, during this recent video series, one of the sections covered a diagram that was not to scale, representative of the solar system, the inner solar system, from a top-down 2D view, conveying the point that Mercury and Venus should not be visible from Earth due to the nature of the heliocentric model itself, how day and night work theoretically on a globe. In summary, day is the period which an observer would be on the side of the hypothetically spherical Earth that's facing the sun, and night is the opposite period in which the same observer has allegedly spun, 12,500 miles around a giant curve at 1,000 miles an hour near the equator, and eventually is facing away from the sun after going through the dusk, twilight phase. Now, these two periods in between day and night are called dusk and dawn, or simply twilight. I got so many comments from people misunderstanding the concept of the terminating line or twilight on the last video, so I have to point this out very clearly and make sure that y'all know what I'm talking about. During dusk and dawn, which that can last anywhere from 25 to 45 minutes, depending on the season and depending on your latitude and other conditions. So, on average, twilight, dusk plus dawn, comprises roughly an hour up to maybe an hour and a half of each day. Half of it in the morning and half of it in the evening, generally speaking. Now, there are a few key factors to keep in mind here which sort of complicate the issue. The first being atmospheric lensing or refraction, the second being electromagnetic birefringence, and I'll put in sort of parentheses there, hypothetical gravitational lensing, which we must include if humoring the heliocentric model, and three, the light from other planets, aka wandering stars, must be reflected light from the sun, according to the heliocentric model, which will have a big impact on this, as you'll soon see. Now, we'll start with these few points in particular because they're an important foundation to start with before continuing. So, the first one, atmospheric lensing or refraction plays a huge role in how we interpret the light coming from celestial objects, in this case, the sun. Mainstream science argues that these sunsets and sunrises we experience are technically longer than they should be because the light from the sun essentially bends around the allegedly curved atmosphere to meet our eye, even though the sun itself has actually traveled beyond the horizon physically And even 8 minutes prior to that, hypothetically, assuming 93 million mile distance to the sun, it takes light 8 minutes to reach our eye. But we're not even talking about that. We're talking about the sunlight actually bending around the curve of the Earth due to atmospheric refraction. So we have two things here. We have an actual sunset or a true sunset, which is not observed accurately, as it will occur first in reality. So the sun will actually set first from the ground in any model, in either model. Then a bit later, due to atmospheric refraction, amongst other things as we'll get into, but especially due to atmospheric refraction, after the sun has truly set, a bit later we then experience the apparent sunset due to the way light behaves when it passes through an atmospheric medium, essentially bending around the alleged curve of the Earth to meet our eye, even though the sun should not technically be visible, and continues to light the eastern portion of the sky, even on towards the western portion of the sky, once an observer has theoretically rotated beyond the true line of sight towards the sun. So in humoring the heliocentric model, we must assume that the twilight hours are always going to sandwich day and night due to the angle of the sun upon the observer. Now, we also must assume that daytime gets a little bonus on both ends, or a little advantage on both ends, since sunlight apparently, according to the heliocentric model, travels through the atmosphere along a curve, propagating further than it normally would, allowing us to see the sun for a longer period than it should technically be visible. Now, this is not a claim of mine, nor do I necessarily agree with it, the claim, but this is a claim of modern Earth science. Now, I totally agree that atmosphere bends light, but I disagree with the idea that the Earth is a sphere, and with the atmosphere being spherical. So I disagree with that. But I do understand the principles involved with atmospheric refraction, and that plays a big part in this, which we'll get into in a bit. But I just wanted to be very clear on this. What this essentially means is that the light from the sun is propagating through the medium of our atmosphere, creating an optical illusion, whether the Earth is flat or spherical. It doesn't matter. This allows us to see sunlight for a longer period than if we had no atmosphere. Now, during the daytime, the atmosphere is rendered totally opaque to everything but sunlight and moonlight, so you can't see the stars or the wandering stars or the planets during the day. And the only celestial lights visible during the day are the sun and the moon. Wandering stars such as Jupiter or Venus or Mercury are visible in the twilight hours and for a short duration before sunrise and after sunset, and then of course at night after the sun has totally set, even after it has totally apparently set. Now, in terms of the apparent sun versus the actual sun that I've sort of just described, this is something that I've been trying to describe and promote, people to consider and get thinking about a lot on several live shows and even some of the videos that I've done. Now, I recently watched a video that described what I've been trying to explain perfectly. I think they really nailed it, and so I'm going to play a clip of this video and give special thanks and props to Dr. Zack. I really hope that Dr. Zack takes this as a compliment and does not try to give me a copyright takedown strike, as my use of such clips are legal under the Fair Use Act, and I hope that we flat earthers can stick together and freely sharing information, ideas, and footage. Fair use laws allow for use of video clips if they're being discussed for documentary, scientific, debate, or exploratory purposes altogether, and I will reserve my rights to exhibit this clip under the Fair Use Act. I doubt that Dr. Zack will try to pull this video. I really doubt it. I hope not. as this is a quest for truth and a compliment that he was able to model out and animate something that I've been trying to explain or describe or to get people thinking about for quite a while, actually. And again, I think he totally nailed it. So I'll leave a link in the description to this video, and be sure to give Dr. Zack a sub, because he and the people he's working with are doing an awesome job all across the board. So roll that clip.
The flat Earth model had a big problem, a very big one, and I think we solved that problem.
How many of you think that the flat Earth model doesn't make sense because the sun would never rise and set, but instead be visible 24 hours a day? Welcome to the Steve and Dr. Zack show.
Now, if you ask any scientist about his opinion about the flat Earth, he will ask you this: how do the sunrise and sunset work on the flat Earth model? And the flat earther will answer, perspective. Well, that is not enough. I mean, perspective is just a little part of the answer, but it's not enough. So the scientist here debunks the entire model with one question. That was my only problem ever since I started to study this flat Earth model. I knew it was not the only reason why the sun disappears the more it moves away from us, you know. And 15 months ago, I started to work on this with Chandra Seke, aka The Man, and then we teamed up with Steve Torrance, and together we solved this puzzle.
The answer was always in front of us. We just didn't see it like fish don't see the water. Now we can model it and understand the flat Earth model more than ever before.
Now let me summarize the story for you. At the beginning, we thought about something that we could add to perspectives to understand how the sun works, because we were sure that perspective was not the only reason why the sun disappears behind the horizon line, but we were not sure if our theory would work, and we had no idea how to test it. Steve already had a flat Earth model designed in his software, but there was something missing from it, and this something was the atmosphere. And we had no idea how to add this atmosphere to his model, if you know what I mean. If you take a look at any animation of the flat Earth, the atmosphere is always missing. It's like drawing the flat Earth in a vacuum of space. And this is why the sun never sits on the flat Earth, because there is no refraction. Now my question is, have you ever seen an animation of the globe Earth model with the effect of the atmosphere? I'm not talking about just drawing the clouds or the air. It's not just drawing them. It's how to make them work as they do in real life. You know what I mean? They know how the refraction works and they know how the atmosphere works, but they never add it to their animation, you know. And if they do, the sun would never sit as they claim it does. And we can prove that too.
Modern science claims that the apparent sun sets after the real sun because of the atmosphere and the effect of refraction. So when we see the apparent sun above the horizon line, that is just a reflection of the real sun, which is already set. But when we added the atmosphere to the globe model, it did the same thing that it did on the flat Earth model. The apparent sun goes down first, and the real sun follows it. That is contrary to the way refraction is normally presented.
So the atmosphere is something that we can't ignore. It's like looking at the sun with your glasses on. The atmosphere is like a lens with no cover. We are like fish in the sea, you know. So the atmosphere can change the whole view of the sun. Now, in order to prove this, we had to add the atmosphere to Steve's model, but the question was how? It was not an easy thing to do, and by coincidence, Steve found out that his program is capable to model the atmosphere exactly how it is. So he took the data from the internet and built all the layers of the atmosphere, and suddenly the magic happened and everything started to make perfect sense. And when I say everything, I mean everything. The sun started to rise and set, and it started to match reality more than the globe model does.
With 3D software, you can model the atmosphere very accurately using refraction settings. We're not talking about drawing it and making it visible, we're talking about drawing the layers with their real effects on sunlight. Once I discovered it, I told my team, guys, we've got a solution. We can test the atmosphere's effect on the light.
After we had everything fixed, we started to compare it with real life. We actually took some real sunset videos and compared them with both the flat Earth model and the globe Earth model. And guess what? If you play the 3 videos at the same time, you would not know where the flat Earth model is because it really looks like real live videos.
Many scientists think that the flat Earth model can't work because it can't represent sunrise and sunset. What are they going to say after studying this proof? Is it going to make sense to some of them now? They can't ignore the atmosphere, and all we did to make the flat Earth model work was add the atmosphere exactly how science represents it. We didn't make it up.
Now, solving this problem doesn't mean that we solved everything. We still have a problem with the elevation angles, because the sun that we see is not in its real position. What we see is just the apparent sun. So imagine the real sun is here and the fake sun is here. The shadow that you're gonna get is going to follow the apparent sun and not the real sun, and this is not what we want. Okay, so the elevation angle that you're gonna measure with the sextant or with any other tool is not the angle of the real position of the sun. It's just the angle of the apparent sun. And we're still working on how to locate the real sun that we never see. Once we locate it, we will be able to get the exact elevation angles of the real position of the sun. And by doing that, we can draw the flat Earth map from scratch. I couldn't continue drawing the flat Earth map with the triangulation method that I talked about a few months ago, if you remember, because I found out that I was triangulating the fake position of the sun. So triangulating the sun from 3 different positions is like triangulating 3 suns at the same time, and that will never ever give you a precise number. So that is why I stopped plotting the map, and right now I'm just focusing on how to locate the real position of the sun.
When the sun is directly overhead, the refraction is near 0, but you still can't say where the sun actually is. As the sun travels towards the west, the atmosphere creates an image of it for every eye. So anyone who looks at the sun from the same angle as you, but from a different city, will see the apparent sun in a different position. But no one can see the sun in its real position. So if you try to triangulate the sun, you will never get the exact distance. This is like trying to triangulate a rainbow.
So if you've ever heard me trying to say many times in the past that it's sort of naive, I'm quoting myself here or paraphrasing, but I've said or alluded to the fact that it's sort of naive to try and triangulate the sun based on its apparent position and angular size, because if I'm standing in one location and find the direction and azimuth to the sun, I'm looking at a mere rendering of a technically invisible light source in the visible spectrum as it passes through the medium of our atmosphere. So I'm not actually seeing the sun, I'm seeing light that has been perturbed a great deal by several factors, least of which is different layers of atmosphere. The apparent position of the sun is subjective, and since we all live on the ground, more or less close to sea level in the troposphere, covered by layers and layers of varying density gases, the way in which electromagnetic waves propagate and diffuse and refract while traveling through such medium as atmosphere, our reckoning of where the sun is cannot possibly be accurate. The same thing goes for another observer hundreds of miles away, as the apparent position of the sun would be subjective according to them as well, depending on a variety of atmospheric conditions, and simple observation of the sun from the ground can only produce biased observations based on subjective conditions for each observer. And again, this is because the atmosphere itself sort of behaves as a convex lens, getting more and more dense as it gets further away from you. So uh, if you can sort of think of like being in a thick fog, if you see fog at a distance, it seems very thick and dense, but when you get into the foggy area, you can see fairly well. You can see through the fog when you're in it, but when you're further away from it, it becomes opaque. So the atmosphere sort of acts like that in a sense that um, it gets exponentially thicker the further away it is from you, if that makes any sense at all. Um, anyway, the whole point of this is where you reckon the sun to be is subjective based on if one thing, atmospheric conditions. Now, the second thing is electromagnetic birefringence. I would add that along with atmospheric refraction and how light waves behave when passing through physical media, such as varying layers of atmos plane, there's another major factor in play which will alter or distort our reckoning of where the sun apparently is at a given time, and that is, of course, electromagnetic birefringence. Due to the Earth's electromagnetic field, in either model, there is indeed a EM field. Electromagnetic waves will alter their course wildly when passing through electromagnetic fields, producing an effect called electromagnetic birefringence. Now, the easiest way to explain what birefringence is would be the good old spear fishing analogy. If you've ever tried to spear a fish in, waist deep water, if you aim for the fish, you're going to miss because the water causes birefringence. It causes the fish to appear in a place that it actually isn't. So, in order to hit the fish, you have to distrust your eyes and adjust or account for the factor of birefringence. Now, at any rate, electromagnetic fields can have the exact same type of effect on light waves, meaning we have yet another factor which displaces or distorts our reckoning of the apparent sun, which cannot possibly be where the sun truly is. Um, Humoring the heliocentric model, this electromagnetic field would need to be generated by molten metals, which is physically impossible as you cannot magnetize molten metals, but that's another discussion altogether. Assuming the globe generates an electromagnetic field somehow, this will certainly play a role in refracting light waves and allow for the apparent sun to linger for longer than it technically should, compared to a scenario where the Earth had no electromagnetic field or atmos plane. Now, I would add that in a flat Earth scenario, the electromagnetic fields really do lend credence to the idea that light waves coming from the sun are traveling in directions that we may not expect. We all think of sunlight, sort of as this perfectly rectilinear wall of light coming in, towards the Earth at the same angle. And then in the flat Earth model, we think of it, the sun as a single point in the sky, throwing off light at converging angles. But it seems like it's even a little more complicated than that in the flat Earth model, because the sunlight, or the apparent sun, or where we reckon the sun to be, appears to be subjective. Again, it's based on subjective conditions of where you're standing and the atmospheric conditions, electromagnetic conditions, and finally, if we're humoring the heliocentric model, we must also include gravity, as it is assumed that gravitational lensing also occurs, which would amount to yet another perturbation which bends light from the sun around the space-time warped by the Earth, allowing the apparent sun to linger for longer than it should, compared to a situation where gravitational lensing does not occur in theory. This is all, of course, theoretical, but we have to include all of the aspects of the globe Earth logic and laws in order to depict this properly in globe Earth terms. Have you ever watched the sunrise or sunset? Do you see an abrupt change from day to night where there's blue skies 1 minute and then just a few minutes later you have a sky filled with lots and lots of bright stars? Of course not. When the sun sets, gradually stars will start to pop into view, planets first. As the evening progresses, after twilight, more celestial lights are peppered overhead, most prominently starting in the west, furthest from the sun. And eventually, after sunset is complete, the number of stars appears to increase, and all the stars just, seem to get brighter and brighter for a time after that until you reach a certain point, an hour or two after sunset when, the stars will be at their brightest for the rest of the night. Now, similarly, as the sun begins to rise, we apparently see the refracted light from the sun first, showing us an apparent sunrise prior to the point when the sun has actually risen above the horizon. Then we have dawn, twilight, and finally sunrise. So the main point is there is a transitional period between day and night, which is a gradual phase and not an abrupt change. Furthermore, this phase is lengthened by conditions including atmospheric refraction, electromagnetic birefringence, and finally theoretical gravitational lensing if we're fully humoring the globe model. Now, this means that any beam of light that passes along the horizon has two forces, in quotes, forces if you will, pulling the light towards the ground or around a curve for argument's sake, and a third theoretical force also bending, these incoming light waves around the curve of the Earth, allegedly. So, I think what I'm getting at here is, if you're looking at sort of a top-down view of the spinning sphere Earth and an observer at the equator looking for Venus or Mercury, for that matter, is going to have to wait until a specific alignment is occurred, and it is my contention that the line of sight of such an observer is going to be a tangent to the curve of the Earth, and Mercury, for 100% certain, would not be visible after sunset. Mercury should be, if it could possibly be visible, would be always aligned to the daytime side of the Earth. Venus, it may come close, but we'll get into that in a minute because it's just blown out of the water. Totally. Now, another thing we need to consider, this is the third thing I mentioned, is before we really get into this, the light from the other planets, aka the wandering stars, so Venus or Mercury, this light must be light reflected from the sun if we're humoring the heliocentric model. Now, I think that it still may be reflected light in the flat Earth model. I think it's irrelevant, but humoring the heliocentric model, with all the background that we've gotten into out of the way, we need to remember that the heliocentric model necessitates that the light that we see coming from the planets is reflected from the sun. This means that given the conditions needed to see Venus, for starters, it would be a very rare chance to catch Venus in the sky, since its orbital path is allegedly tighter around the sun than the Earth's. Meaning, if the conditions were somehow in place to have a line of sight towards Venus, it would not be fully lit, but instead it would only be partially lit due to the angle of the reflected sunlight. I will slightly modify or correct my previous claim that Venus would never be visible, and instead assert with certainty that according to the heliocentric model, Venus should probably not be visible from Earth, although there may be very rare circumstances when it would be visible, or at least a line of sight may be achievable in such rare circumstances. However, in these cases, it would only be partially lit due to the angle of reflection from the sun. This is still a stretch, as I still reserve the possibility that the proclaimed orbital path and distances of Earth compared to Venus, along with the daytime sky obstructing all celestial lights, coupled by the fact that the sunlight lingers above the horizon for longer than it technically should, which means that our angle away from Venus's orbital path would be exacerbated by this fact. Finally, the tangent line of sight from an observer on the Earth from the evening side, or morning side of the Earth towards Venus would be divergent to the orbital path of Venus, and I believe that it is still a good possibility, or still maybe up in the air, but I reserve the possibility that according to the heliocentric model, Venus would be rendered invisible forever due to everything I've just mentioned. But even granting the heliocentric model the visibility of Venus under very special circumstances, the orbital path of Mercury, on the other hand, would undoubtedly never intersect with the line of sight of any observer during the sunset, twilight, or early evening hours. It's impossible. That would never happen. Mercury itself should not ever be visible from Earth, period. Its orbital path would simply never intersect with our line of sight during any period other than daytime, since we all know that you can't see the stars or the planets, the wandering stars during the day. The heliocentric model simply does not work, as we can view the wandering star Mercury after sunset, well after sunset. This observation simply doesn't work in the heliocentric model. Given the fact that the atmosphere is opaque during the day, and Jupiter's orbital path would only be within our line of sight Mercury's orbital path would only be within our line of sight during the day. And again, Venus, I would say, probably falls under this same category. It's very close, but certainly Mercury. So essentially this falsifies the heliocentric model. Now, I found an interesting thread. I was searching online for information about Venus's visibility, and I'm going to read through this, as some random astronomer was baffled by the fact that Venus was visible years before Flat Earth came out, and this guy was making observations that obviously didn't make any sense in the heliocentric model. And what you'll see happen was people just sort of convinced him that they knew better and that he didn't have a point, but they totally didn't talk about Mercury. Okay, so I ran into this thread on a general discussion forum on giantbomb.com. I'll put a link in the description. But this was from 6 years, 5 months ago. I need an astronomer or a planetary science man to explain this to me, but apparently you can see Venus in the night sky. How does that even work? This story's explanation makes no sense whatsoever, and there's a link to the story that they give as to why it's possible that Venus is visible in the night sky. I read into it. It doesn't make much sense, like he said. And I'm continuing with the quote. At night, the planet is dark because the surface we're living on is facing away from the damn sun. We see the moon because the moon is behind us as well as reflecting the light off the sun. But how is it possible to look at Venus when that bloody planet on an inner orbit? Like, logically, if you think about it, there's no way to look at Venus while we're away from its general direction, so there's no way for its light to even reach our faces. This is driving me nuts. Then you get a bunch of people who try to explain this away from him, and eventually, and the guy, like, you can read it for yourself. I'm not going to read the entire article, but I will link it up. The guy's making some pretty, interesting arguments. Again, this is not to scale. I'll go through something that's a lot closer to scale here in a minute. But if you notice, they don't show Mercury in this because indeed Mercury would be invisible, and as I've already mentioned, the angular size of Venus and Mercury, according to the laws of reality and how optics work, they would technically be too small to see by, especially Mercury, a 3,000 mile diameter object being visible a minimum of 77 million miles away. It's physically impossible, especially considering the darn thing would be, half lit or a quarter lit. With an indirect reflection is all that we would see of it if it could be seen. But just thought this article was funny. Check it out. Again, the Globers ultimately win and make the guy feel stupid and convince him that Venus would be visible from the night side of the Earth. Yeah, I thought it was funny because it was 6 years ago. This guy was really onto something. He couldn't, he found a glitch in the matrix, a glitch in the heliocentric model, and it's almost like they put Neo back to sleep. So, he took I guess he took the blue pill or whatever. Now, this would be a little bit more to scale representation of the inner solar system with the again, this is all hypothetical, humoring the globe Earth model. This would be the Earth's orbit here. That would be Venus's orbit there. And of course, Mercury's orbit. And then the sun. Now, the reason I said this is somewhat to scale is because what I did was, and I'll just zoom way in here on the big old sun. I made the sun exactly 1 inch in diameter. Okay, and so we'll consider that 1,000,000 miles. The sun's about 1,000,000 miles across, right? So, 1 inch equals 1,000,000 miles on this. Okay, so I made the square of this document 200 by 200 inches. So it'd be 200 million miles this way and 200 million miles that way. I'll zoom in here on the Earth because it's going to be about to scale as best as I could get it. That's not the Earth. You got to keep zooming in. Keep on zooming in. Okay, so the Earth is this little blue dot right here. I think I put it as 0.01 inches. So yeah, 0.01 inches. It would be a lot smaller than this, but that's about as small as I could get it. Anyway, you can sort of see the relative size of the sun up next to that tiny little dot, the Earth. This is the wall of light coming in from the sun. This circle here would sort of generally represent the distance to the moon. And you can see what I mean, that in the moon's cycle it would be on the day side of the Earth for roughly half of each month. Okay, now before delving into this diagram a little deeper, just going to go over a couple of these facts again. The alleged orbital path of Venus is supposedly 67 million miles from the Sun on average. and its inclination to the ecliptic is 7.01 degrees. So it's not that much. And just to show you what I mean by the inclination to the ecliptic, this would represent the ecliptic, or the plane around which the Earth orbits the Sun, and Venus's orbital plane would be offset by about 7 degrees. Going back to it, the diameter of Venus is 7520 miles, traveling 78,000 miles an hour. It has a 224 Earth day orbital cycle, so it takes 224 days to go all the way around once. And what I thought was very sort of odd is that it spins at 4 miles per hour at the equator. Wow, that is slow. Until you look at Mercury, of course. But now, again, these are all just allegations of the heliocentric model. Looking at Mercury here, this red orbital path, and again, these would be offset ellipses, but we're just talking about averages here, make it simple. The alleged orbital path of Mercury, supposedly 36 million miles from the Sun on average. Diameter of 3,032 miles, inclination to the ecliptic about 3.4 degrees. So again, that's this here, inclination to the ecliptic. Allegedly traveling at 106,000 miles an hour around the Sun, and it takes 88 Earth days to make one orbit. So 1 year on Mercury would be 88 Earth days. And you thought 4 miles an hour was slow. Well, Mercury allegedly spins a mere 4 times per Earth year. So it would have to actually go around, well, it would have to go around the Sun 4 times to spin 4 times, roughly. I think it spins, the way that they say is it spins twice on its axis every 2 orbital cycles or something like that, but the damn thing's barely spinning. All this is sort of irrelevant. I just think it's very interesting at how stark contrast we have in terms of axial rotation here on the Earth. Mercury spins 4 times a year, Venus spins 4 miles an hour, and the Earth allegedly spins 1,000 miles an hour at the equator. That's pretty drastic, pretty dramatic, honestly. Now, getting past this, this diagram is assuming the ecliptic as the Earth's orbital plane. You notice that we're tilted to that, and that's how we allegedly get our seasons. But actually, the diagram should look more like this, because allegedly the Sun is traveling at close to 500,000 miles an hour around the so-called galactic center, and all of these orbital paths, or the Earth's orbital path, is offset to the path of the Sun by 60 degrees. So to me, this really sort of defies gravity. It makes you wonder how the Earth, for example, is able to maintain this perfect plane of orbit relative to the Sun as the Sun is in motion. Now, I know everyone's going to say, well, it's gravity. But honestly, if you think of the Earth going around in a circle this way, passing out, in front of the Sun, then looping back around and coming, back in the opposite direction that the Sun's traveling, and maintaining this perfect plane of orbit, does not jive well with the idea that there's a constant tugging towards the center of this mass of the Sun. You would think that at some point these planes of orbit would start to, rotate this away, or, but no, they always essentially adhere to this plane of orbit, which is very, very odd to me, and, humoring the heliocentric model. And I know you're going to say that I don't understand gravity, but I do understand gravity, and I believe that it is you who claims that this isn't that big of a deal in an orbital sense. I would claim that you don't understand gravity. Gravity is supposed to be warping three-dimensional time-space and sort of creating a suction in all directions towards that center of mass, while that center of mass is traveling, and these tiny little objects are maintaining perfect. I mean, what is there, a floor here and a ceiling here to make sure that they don't stray from their perfect path of orbit. I mean, it really, not to mention, and do so in perfect cycles. It's really just baffling to the mind to consider the heliocentric model and how we fell for it. Actually, this is just giving you an idea, sort of a side view of the northern winter. You've got your 23.4 degree tilt. This would represent the ecliptic. Again, the ecliptic would be this blue line or this blue line, or essentially this plane, described by this circle. So that's the ecliptic, and remember that these other circles are offset to that by a little bit, not by much, but by a little. And so I don't think that they would affect visibility too much. The reason, again, that I would argue visibility is affected is by sheer line of sight. So again, zooming in on the teeny tiny 2-scale Earth, according to the sun, or pretty darn close to 2 scale. Once you pass over sunset through twilight, and again the sun sort of gets a boost on both sides of this due to atmospheric refraction, electromagnetic birefringence, and of course gravitational lensing according to the heliocentric model. So you're gonna have this sort of tangent angle to the curve, constituting visible space, and a planet such as Mercury would simply never be visible. That line of sight is never going to converge with this orbital path. And giving Venus, again, which is debatable, it's close. And I know people are going to argue, well, of course, we see Mercury and Venus, so you don't know what you're talking about. But the point is this is disproving the heliocentric model and showing that Venus and Mercury are doing something other than orbiting the sun. Okay? And by the way, neither are we. The Earth is stationary. The sun goes, in circuits above and overhead us. So here's just sort of an enlarged top-down view of what we're describing here. You can see you've got the day side of Earth. You've got sort of the twilight hours. I would say that the sun gets a 30-minute boost. I don't know. From the atmospheric refraction. So 30 minutes after sunset would be somewhere around in here. And again, your line of sight is going to be a tangent. That's actually giving it some credit there. It should be a wider angle going that way. But your line of sight is going to be a tangent to that curve. And just to put this in a little bit better perspective, there's no way to show how small a person would be looking, off into space from here, trying to see Mercury or Venus. But just to give you sort of an idea, since this is a sphere, there's a little guy, but not that little guy, the other little guy. No, not him, the littler guy, no, the littler guy. No, the littler guy, so this doesn't even begin. This would be like where the ISS is. So, but you can see that looking straight, parallel with the ground is going to appear to be a convergent line with the ground due to the laws of perspective. However, in order to see, stars over the horizon, you're going to have to look up, so, a few degrees up. You're not going to look down towards the ground. You're not going to look directly at the or parallel with the ground, because again, your line of sight converges with the ground. So in order to see stars or planets, you're going to have to look up. Your line of sight's going to be a tangent to the curve of the Earth. So just backing up all these little guys sort of gives you an idea of how small we, the observer, would be on this spherical Earth. And when you get over to, here, and you're trying to see around this huge curve, you're trying to see something that's, when you're trying to see something that is on the day side of this area, which is the day side, the orbital path of Mercury would never intersect. Now, again, when Venus is at its closest, it would be at high noon. And when it's at its furthest, it would be at high noon on the opposite side of the sun, right? Same thing goes with Mercury. When it's at its closest, it would be at high noon. And when it's at its furthest away, it would be at high noon, but on the opposite end of the sun, so you'd never see it. And not to mention, this orbital path would never converge with your line of sight from the Earth. Okay, since we've covered some mind-boggling proof and conversation that the heliocentric model is totally wrong, or at least very questionable, I mean, come on. If for no other reason than Mercury is visible at all, as it should certainly always remain hidden by the blue sky on the day side of the Earth. Regardless of any conditions you can possibly imagine, the planet Mercury should never have been discovered, and Venus may just fall under that bucket as well, but certainly Mercury. The reason I say the same can be argued about Venus, and I concede that there's an extremely minute possibility that Venus may be visible, or at least aligned to the line of sight during the twilight or night hours in the heliocentric model. During extremely rare circumstances, Mercury, on the other hand, is 100% slam dunk in terms of falsifying the heliocentric model. This, of course, pales in comparison to the fact that we can see many of the same constellations 90 degrees overhead from the equator from season to season from somewhere on Earth, when technically, say, summer stars should exist southwest of the galactic equator, while winter stars should exist northeast of the galactic equator. Yet we can see all of the same constellations from season to season, again, even 90 degrees overhead from the equator, which is physically impossible in the heliocentric model. So this whole argument is an extension of this premise, merely adding another layer of observable proof that the heliocentric model has gotten it all wrong. Now, the smallest angle under which an object can be seen is upon an average for different sites at the 60th part of a degree, or 1 minute in space, so that when an object is removed from the eye 3,000 times its own diameter, it will only just be distinguishable. Consequently, the greatest distance at which we can see an object, say a coin that's an inch in diameter, would be 1 inch multiplied by 3,000, or about 250 feet. So if the diameter of Venus is 7,520 miles, the object would become too small to see at 22.5 million miles. Now, at its furthest, according to the heliocentric model, Venus is 162 million miles. That's way more than 7 times more than where it should vanish. Again, it would become too small to see at 22.5 million. At its furthest, it's allegedly 162 million miles. But that, of course, would mean, at its furthest, it would be directly behind the sun from our perspective. So it would be aligned to high noon on the opposite end of the sun. It wouldn't be visible under any circumstances at its furthest, even humoring the heliocentric model and assuming that planets do not obey the laws of perspective or the vanishing point based on angular size. This is all dictates objects disappear relative to their size at a given distance. Now, at its nearest point, and this is actually the nearest Earth ever gets to any planet, allegedly, according to the heliocentric model. Venus at its nearest point is 24 million miles. Remember, according to the laws of reality, Venus should literally disappear to the sheer distance involved and its size relative to that distance at 22.5 million miles. Yet at its very nearest, it supposedly gets to Earth about 1.5 million miles further than that. And even assuming there's some weird freakish scenario that we could somehow get a line of sight on Venus at high noon, we certainly couldn't see Venus at its nearest at night because technically, not only should it be too distant to see according to its angular size at the nearest point, but this would be at the high noon position of the Earth. Under any circumstances, the nearest that Venus is going to be at the high noon position according to someone standing on Earth, and would simply never be visible at the times when it's at its supposed nearest point, or any of the times, leading up to and proceeding away from that point. Because it would be high noon or 10 o'clock in the morning or 2 o'clock in the afternoon. You can't see the planets during the day. So anyway, even then, even during the time when Venus is at its so-called nearest point, its angular size would render it invisible, even if you could see it during the day. The angular size would render it invisible due to distance, even at its nearest point. Again, when it's furthest from the Earth, it's on the opposite side of the sun at high noon, so it would certainly be invisible. And then for sure, because it's 162 million miles away, according to the heliocentric model. Now, at the very slim portion of its orbit, when I'm humoring the idea that Venus might be aligned, to an observer's line of sight after sunset, even in that bizarre, freakish scenario, which probably would never happen in a heliocentric model, it still couldn't possibly be visible due to its angular size and the distance to the planet, for crying out loud. Not to mention that the light coming from Venus is supposedly an indirect reflection from the sun. So it's not like we're looking at a full moon Venus. We'd be looking at like a crescent moon Venus or a half Venus at best. And so the angular size would be even smaller than than what it should be, because you're not looking at a full-on reflection. And by the way, that indirect reflection would be less bright. I mean, this planet Venus should not be visible in a heliocentric model. Now, indeed, I stand by my assertion that Venus should never have been discovered if the heliocentric model is correct, as the conditions involved with the model do not allow for it to be visible due to the opaque atmosphere at the daytime, and the angles involved with the line of sight after sunset, and finally the angular size of Venus relative to the distance involved, made worse by the alleged indirect reflection we should be witnessing, when it is often one of the brightest objects in the twilight hours. On to Mercury. It's supposedly 3,032 miles in diameter, very tiny compared to the Earth and Venus. At its nearest, Globus claimed that Mercury is 77 million miles from Earth. That's at its nearest, 77 million miles, and at its most distant at 222 million miles. Now, if you consider the laws of reality, which dictate objects become too small to see based on their size and distance, if we multiply the diameter of Mercury by 3,000, then the object should disappear at 9,096,000 miles. Even in some freakish event or eclipse, since Mercury's path would always fall on the day side of Earth. Again, when it's at its nearest, it would be aligned to high noon. At its furthest, it would be on the opposite side of the sun at high noon. So there's simply no way we can see it during these periods. And again, due to the line of sight of the observer being a tangent to the curve of the Earth, and the orbital path of Mercury would simply never intersect with our twilight or nighttime hours under any circumstances. But even if Mercury were somehow visible at night, or under some weird, impossible circumstances, the object would physically be so small in terms of angular size that you would never see it. It would be too small to see, and yet we can see it with the naked eye when it's a minimum of 77 million miles away and is only 3,000 miles in diameter. I mean, give me a break. An object of that size at that distance would physically be too small to see, and any light reflected from it theoretically would again be indirect, sort of half-lit light, because again, you're never going to see it at high noon under any circumstances. But that light would attenuate into the background radiation many millions of miles before the light ever reached the Earth. Now, if you think that you can see an object that should disappear at 9 million miles from 77 million miles away, minimum, I think you need to get your head checked. Seriously. I mean, I'm not trying to offend anyone, but if you want to stick with the globe, then you must believe the impossible. You must believe that you can see an object that's 3,000 miles in diameter from 77 million miles away when it should disappear altogether from any possible sight at 10 million miles away. Yet we can see it with the naked eye from the ground. I submit that if you had any doubt in your mind whether the heliocentric model was a working model, I hope you realize that it simply doesn't work based on simple, verifiable, repeatable evidence. I hope more of you are able to participate in true science, which is flat earth science, as opposed to theoretical science, which is preposterous folly and truly pseudoscience. I'm going to end with this picture of Jupiter, Mercury, and Venus nearly aligned well after sunset. I realize that the heliocentric team is going to try and explain this away. However, I'm 100% convinced that we can chalk this single image up to undeniable proof that the heliocentric model does not accurately describe observable reality, and we must rethink our position on what we believe to be true. If you choose to believe that you live stuck to the side of a spinning sphere thanks to the theory of gravity, which has never been demonstrated or proven, zipping around a giant curve at over 1,000 miles per hour near the equator, flying 66,600 miles an hour around the sun, at a 60-degree angle to the sun's path around the galactic center at nearly 500,000 miles per hour, as the galaxy hurls through space a gazillion miles an hour, and you think that I'm crazy for believing in wild theories? Take a reality check for just 1 second, please. See a 3,000 mile diameter object from 77 million miles away minimum. What is wrong with you people, astronomers? we really don't even need astronomical evidence to prove the world is a stationary plane, but the more holes we can poke in the quite ridiculous heliocentric model, the better. I hope this video has helped you to understand the proof involving the planets Venus and Mercury a little bit better, and how we never should have discovered them under any circumstances, especially Mercury, probably Venus. But either way, it's proof that the heliocentric model doesn't work. I hope that more of you will consider the idea that the flat Earth reality is much more than a theory and is much more rational and simplex than the spinning sphere, gravity, Big Bang theory. I've mentioned before that not only do the planets or wandering stars mentioned so far debunk the heliocentric model in so many ways because we can simply see them, but so does the moon. The moon should only be visible during the day for a little less than half of each month during the phases surrounding no moon or new moon. Due to the same principles I've mentioned, the day side of the Earth always being facing the sun and the night side of the Earth always being facing away from the sun regardless of the spin. If the moon takes a month to go around, then it would be on the day side of the Earth for a little less than half of each month during the phases again leading up to and leading away from no moon. Conversely, the moon should only be visible during the night for the cycles surrounding the full moon. This is basic geometry and basic common sense, and the fact that we can often see near full moons during broad daylight or waning crescent moons in the middle of the night clearly prove the heliocentric model is dead wrong. Thanks so much for watching. Much love to all my subscribers and supporters. Don't forget to double check, make sure that you are still subscribed and you didn't get unsubscribed. And if you haven't subscribed, then go ahead and subscribe. The Globe is Dead 3 will be back up soon enough. But until then, I'm going to wait to finish that series with part 4. I've already got it pre-recorded, but I don't want to release it until I've got part 3 dealt with. Anyway, until next time, thank you all so much for hanging in there. Spread the word, spread the world, and peace.